Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel can be found at smarturl.it/pass actuarial exams. Here you have links to the online seminars for exams P, FM, IFM, and LTAM that I teach, as well as to study manuals for those exams that I wrote. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P. An insurance policy reimburses a loss up to a benefit limit of 10. The policyholder's loss, y, follows a distribution with density function 2 over y cubed for y greater than 1 and 0 otherwise. What is the expected value of the benefit paid under the insurance policy? So let us note two things here. That this is a benefit limit, not policy limit, but it doesn't make any difference because there's no deductible. And secondly, this random variable is non-negative with probability 1, non-negative almost surely, so you can use the Darth-Vader rule to calculate expected values. However, it has an important property that the values of this random variable between 0 and 1 have 0 probability. And that means that the survival function for positive values of y starts out being 1 from 0 to 1, and only then, after y exceeds 1, the survival function starts declining. And here's the solution. So the amount paid under this policy is W equals y when y is between 1 and 10 for y greater than 10. And the expected amount paid is E of W equals integral from 1 to 10 of y times 2 over y cubed dy, so the value of y, which is what W equals to for y less than 10, times the density, which the formula for the density for y greater than 1 is 2 over y cubed. So y times 2 over y cubed dy, plus the integral from 10 to plus infinity of 10, which is the payment for any value of y that exceeds 10, times the density, which is 2 over y cubed dy. Okay, so the first expression is really, the integral is of 2 over y squared, and the integral of that is minus 2 over y, and we evaluated from 1 to 10. And then the second expression, the integral of that is 10 over y squared, well, minus that, really, minus, but I put the minus in front of the whole expression. It would have been nicer if I put it inside, but it doesn't matter. So anyway, it's either way there's a minus there, because of course y to the negative 2, if you take the derivative of that, you get minus 2y to the negative 3. And we evaluate this from 10 to plus infinity. And that becomes, so this, by the way, the second integral at infinity is 0, so that 0 value is irrelevant. The first one is equal to 2 minus 0.2, and the second one, the value at 10 is 10 over 100, so 0.1, with a plus sign because we're subtracting that from the 0 at infinity, and that's equal to 1.9, which is answer D. But of course, whenever you can, you should use Darth Vader rule for practice, for pleasure, for fun. So that failure approach is also possible, and it's, as always, more interesting. In this case, the survival function of y is 1 for y less than 1. And I told you that at the very beginning. And then it's the integral from y to plus infinity of 2 over s cubed ds. I can't use y because I already have y in the integral being from y to plus infinity. And the integral of 2 over s cubed is minus 1 over s squared, because this is really minus s to the negative 2. When you take the derivative of that, you get minus negative 2. So 2 times s to the negative 3, which is 1 over s cubed. So this is evaluated from s equal to y to plus infinity. So basically s going to infinity. At infinity, it's 0. At y, it's minus 1 over y squared. But we're subtracting it, so the value is 1 over y squared. So this is the survival function. And the expected value of w is just the integral from 0 to 10, 10, because that's the policy limit. Well, the benefit limit, but in this case, policy limit as well. Integral from 0 to 10 of s sub y of y dy, which is split into two integrals because the survival function formula is different. So from 0 to 1, it's just 1. And then from 1 to 10 is 1 over y squared. So we take the integral from 1 to 10 of 1 over y squared dy. And the first integral is 1, and the second one is minus 1 over y evaluated from y equal to 1 to 10. So that's minus 0.1 at 10, and then we're subtracting the value of negative 1, so we get plus 1 at y equal to 1. So it's 1 minus 0.1 plus 1, and it's 1.9, and that's answer D again. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.